To you. So as you know, SAP is a business critical application. It's the leading enterprise resource planning software, which has been in the industry for, I would say, more than 20, 30, 50 years. And a lot of companies are dependent on it. So the training that we have created is basically to educate you about how to deploy this SAP application in the cloud and how to successfully run it. And it could be that you have the on-premise SAP deployment, you're trying to migrate it into the cloud, or maybe you're deploying it brand new. So it will cover both brownfield and greenfield scenarios. So why do we actually need this training? SAP has been there, now you're moving into the cloud. The thing is that when you're moving the applications in the cloud, they need to be optimized. They need to make sure that they are highly available, they have the performance that they need, and with the security and some cost optimization. Yeah. So for that, and the enterprises are looking for some intelligent networking and security software, because what they're finding is that the cloud providers are not providing them what they were enjoying when they were deploying these applications in the on-premise world. So they need a simple, consistent way to connect regions, applications. Maybe they have SaaS, maybe they have the internet connectivity, on-premise, SD-WAN, branches, and whatnot. So they need all. So that's the reason we created this training for you guys, because you guys are the pioneers. You guys deployed this in the on-premise world. You know how networking and security should be done for this business critical application. So that's the reason we are bringing this knowledge to you. And this training is also useful for SAP basis engineers and architects, because they are deploying the SAP from the operating system, from the application point of view, but definitely you need it to connect to the network. Without network, it's not going to work. It's nothing, right? So they need to understand those networking and security concepts as well. So we will focus a lot more on the design. So we're not talking about implementation a lot, but mainly about the design, how to make sure you're getting the full visibility, how to make sure when you deploy, you have the proper security around it. We covered. Then we spoke about these brands that are using Aviatrix platform for various business critical application needs. And then training itself is being used by a lot of companies and has enabled a lot of enterprise architects and engineers in terms of their cloud and multi-cloud journey. What we're going to do in the beginning, we'll cover the public cloud networking 101 for SAP. So we'll cover 3 different clouds, and we'll show you how these cloud they work from the networking, routing, and security point of view, and how they're different from each other. And that's one of the reasons that you need Aviatrix platform that can provide you this consistent operating model, this consistency in terms of deploying and managing your applications. It's going to be fast, so you will have to, kind of stay focused here. And then in 5 hours, you get a lot of education. And after that, we also have a lab portion where you can go into the lab, you can log into the Aviatrix platform, you can see how the networking constructs are deployed in different cloud. And then once you have completed all these requirements, you will be awarded the ACE certification. Okay, so what about Aviatrix? Who we are, what we do, right? So what Aviatrix is providing to the industry is the intelligent cloud networking platform, because we believe that the networks of today, they need intelligence. So what are the challenges for the enterprises in the public cloud? So as an enterprise, as an IT architect, networking architect, when I log into the AWS or GCP Azure console, what I see out there is basically tooling. It's like you walk into Home Depot or IKEA or other home stores, and you see a lot of tools. You have drill machines, you have nails, hammer, and whatnot. But when it comes to building a proper architecture, a house, you need to have some blueprints. You need to have some drawings and whatnot, right? So what customers are saying and telling us that, this is very difficult in the cloud to build, then operate, and then grow, right? Because these are all tools. I don't have a reference architecture. So this is exactly what we also see from our side, is that the cloud is providing you this go and build mentality. Yeah, and then networking folks are not comfortable with that approach. They need a reference architecture that is missing. In the day two area, operations area, they are challenged by the visibility that they're not getting, because in the on-premise world, they had complete control over their hardware and software and the logging systems and whatnot, and they don't see it here in the cloud. And when you're trying to expand your footprint, let's say from one region to another region, or from one cloud to another cloud, it's extremely difficult because there is no centralized control plane. There is no data plane that is consistent across multiple clouds, or take your cloud model to on-premise edges. So it's very challenging. So we said, okay, we're gonna exactly tackle those challenges for our enterprise customers. And we have built the Aviatrix intelligent platform that actually helping enterprises build in the right manner, but also very fast. Yeah, and it's applicable to greenfield and brownfield. So what we have given to the industry is the multi-cloud networking architecture, MCNA. And that architecture is applicable to single cloud, single region, or across multiple clouds, multiple region. And then it can also extend to on-premise data center to your edges. So basically your data center and edges looks like VPCs and VNet from the operating point of view. So we provide the best practices to our customer to design and build this and operate it in a way that you demand from the enterprise side. And then when it comes to growing your application, your footprint, or your business to increase the revenue, we have all the tooling and all the platform features available to support that. So these are the pillars or the founding element that we have as part of the platform. So the first is the consistency in terms of providing the networking, routing, dynamic routing security. The second is the visibility and control, because now you're sitting on the shared infrastructure. It's the data center that you're renting basically. And there are a lot of other enterprises are sitting on the same shared infrastructure. So how do you actually build an architecture which is sitting on the shared infrastructure, but it's yours? So you totally control it and you have complete visibility into what's happening underneath. And the security has to be part of the data plane. Okay, so this is embedded in our data plane. And then last but not the least is the automation, because you need the agility. It's a reality. You need the connectivity or integration with your CI/CD pipeline. So your automation cannot be disjointed. Like in AWS using some other automation, in Azure is something else. In the on-prem, you're still relying on, I don't know, Ansible or Python. No, that's now it is. The platform is actually providing you consistency across the board. So we have this platform with the following attributes. So you have the control and management plane. This is also the entry point for your automation and API needs. Then you have the smart data plane, which is providing all these features and functionalities that I discussed before. And then you have the operational visibility element as part of the platform. Now, when you translate these requirements or these elements into an actual product, this is what you get. So the first is the Aviatrix control plane, the controller. And this is actually deployed from the CSP marketplace. And it's just one highly available control plane you deploy in one cloud. It's not like you're deploying it across each and every cloud, right? So this is providing you the entry point into your automation. It's giving you this centralized control plane, which you don't get from the CSP side. And then you have this smart data plane, which are the Aviatrix smart gateways. They are sitting close to the application, so they can provide the security and networking close to the application. So instead of sending your traffic to some other third-party cloud or somewhere else, which is obviously not going to work, these are sitting close to the application and providing the necessary enterprise-grade networking and security for those applications. And then we have the Copilot, which is again providing you the dashboarding, the consistency, single pane of glass to manage not only cloud, but also the on-premise resources, software components. Okay, so now we'll move on to the cloud networking 101 piece. Okay, so let's look at the how cloud is actually tackling networking and security. So the first thing that you need to remember is that for every CSP, their bread and butter, their revenue generating application or service is basically their instances, the EC2 instance or virtual machine. And that's the reason you will see there is a heavy focus on it. Yeah, because obviously they want to make sure that the applications and EC2 instances are up to date, they have the right sizing, they have special, storage and whatnot, right? So that's their focus. Networking and security is not like top of their mind. Yes, they do provide it, but it just to provide the basic functionality out there so that these applications can talk to each other. So that's the reason you will see that the networking itself is very different in each cloud. And when you look at the routing, BGP, or the way they program the route is very different. The way they connect to internet is different. The constructs are different. The VPN is different. The route that they learn from the on-prem is different from one another. Yeah. So for the same reason, when you're deploying SAP S/4HANA, your deployment is going to be different in each and every cloud, and you need to know how this cloud works. For example, if you are familiar with AWS, but if you're new in Azure and your business is demanding to deploy SAP S/4HANA in Azure because this is where you have maybe good deal and whatnot, it's going to be a nightmare for you, I can tell you. But if you have a platform like this, it's going to become very easy. Yeah. So these are just two examples here where you can see their deployment mentality or methodology, which is very different. This is AWS, and the bottom is Azure. Now, one more thing that you notice is that it's in the cloud is very flat. There is no reference architecture. But the problem is that we know, because we have been in the industry, you have been in the industry for 15, 20 years, you know that you need a reference architecture, because in the on-premise world, you had total control over all the networking and security elements. And you know that when you were building these architectures in the on-premise world, you followed a recipe, a best practice recipe. So you had the access layer, then you had the cloud networking backbone, which is also the core. And then you had the aggregation layer, right? And these networks, obviously, they evolve also. Yeah. So there was obviously a lot of efforts from the industry and or the veterans to make sure that the data center architecture or the WAN architecture was following a reference point so you can properly deploy it and then manage it. Now, when you look at SAP, what is SAP S/4HANA? So basically, it's a 3-tier application sitting on these cloud providers like AWS, Azure, and GCP. And it's actually a software, a Linux software running on EC2 instances or virtual machine. Since it's a 3-tier application, it has web, app, and DB tiers. All these tiers are deployed on a virtual machine. In case of SAP, the web tier is their Fury. It could be some other third-party web system trying to connect to SAP HANA DB. In the app layer, they have their SAP ABAP server, which is again another virtual machine. And then they have the actual database, the SAP HANA database, sitting on these EC2 instances. And every EC2 instance has a specific requirement for these applications. So now we know that it's a 3-tier application. It's a virtual machine, EC2 instance. It has to connect to a route table, to another VPC, to on-premise data center. How does it look like from the networking point of view? So when we look at AWS, and this is AWS Networking 101, when you look at AWS, the first thing that you have to do when you log into AWS is you create an account. So everything actually is under your account. Yeah. And when you create your account, you have a notion of region. So AWS has their data center sitting in various regions across the globe. Obviously, they cannot cover the entire globe, so they have their own limitations out there. And that's the reason you will see some other CSPs, they have footprint in a region where AWS does not operate. And that's another reason to go with the multi-cloud architecture. But yes, so this is the notion you get when you log into the AWS console. Now these regions are divided into their availability zone. So within a large metro area, they have the AZs, so that let's say one AZ or zone goes down, the second is there to take care of the application. Now, once you have done that, now come to the networking part. So networking in AWS, it starts from the VPC. And when you look at the VPC, when you create the VPC, it's basically stretched across a region. Okay, so region is the boundary for this VPC, and within the VPC, you can consume different AZs or availability zones. So after you create the VPC, what you need from the networking point of view is create a top level seeder or CIDR. Okay, so you create that, and then within this top level seeder, you create the subnets. Like here, this is 10.116, this is 10.1.3.24. So you create these subnets. Some of them are private, and some could be public. Public is so that you can actually go out through the default out towards the internet. Private is basically to make sure that your traffic stays within that VPC. And this is where you're going to deploy your application. Obviously, SAP HANA is going to be deployed on the private instances, because obviously you don't want to expose your SAP to the world. So that's what you see here on the diagram. Now, if you look at the number of VPCs you can deploy per region under your account, they have a quota, they have some restrictions, but yeah, most likely it's not an issue. So you can deploy multiple VPCs within a region. Okay, so this is just a basic deployment. Now, what about connectivity to the outside world? You need that connectivity because this is a cloud world we live in. The internet is just sitting next to the application, and how do you connect is basically through the concept of internet gateway in AWS. So when you deploy the EC2 instances, you notice here, these are the private IP addresses, but you can also use the public IP. So if you have the public IP address for your EC2 instance, it can just directly go and talk to the internet using the internet gateway. We need NAT gateways so that these private IP addresses can go out towards the internet using the NAT gateway. And now NAT gateway could be the AWS native NAT gateway, or you can use the EC2 instance or virtual machines to provide that functionality as well. So when you deploy your VPCs, you deploy your subnets, virtual machines, then you create the route table. You associate the route table with the subnets. You can see there is a default route taking the traffic towards the internet gateway. That's the IGW. And then you have the local routes as well. The NAT gateway, as I mentioned, you create that. In this case, this is a native NAT gateway. We associate it with the private subnet, and then your private virtual machines can actually go out using the NAT gateway. Same is true for the SAP instances. If they need to talk to internet, they can use the NAT gateway to go out. What about connectivity to on-premise, to your branches, to your data centers? So for the on-premise connectivity, you have mainly two options. One option is to use the IPsec using the AWS VGW. This is mainly used for the branches, could be used for the data center, but mainly for the branches. And then for the data center connectivity, because you need high throughput here, you would use a service called Direct Connect. So Direct Connect is a service to provide this high-speed connectivity. And the challenge is that what you need to remember as an architect is that there are limitations in terms of the route propagation, the number of routes that this link, the Direct Connect link, can support. That's very important to remember. And the second thing to remember is that, yes, you can get the high throughput on this link, like 10 gig, 25 gig, or even more, but it's not end-to-end IPsec encrypted by default. And when you try to encrypt this link, you're only going to get 1.25 Gbps throughput. Okay, so that's a serious challenge. And you will see that in our platform, we have a solution for that. Then they have their own the routing constructs. So they have their own transit gateway. In some cases, in GCP, they don't, but in AWS, they have AWS TGW, which provides you the connectivity between your VPCs and can also connect to the on-premise world. But what you need to remember is when you're designing it, make sure you look at their documentation and make sure what you're trying to achieve is actually can be achieved with this service. And they have done a really good job in terms of listing all those restrictions. So make sure you go and then check that out before you start using the TGW, because I have seen customers, they did not know that. They started their journey 1 year, 2 years down the road. They ran into a lot of visibility and routing limitations, and they went back to AWS. And obviously, AWS, we are a great partner with them. And if they see this situation, they will always recommend go towards Aviatrix to solve those challenges. So it's better to talk to them early on so that you know your options and can opt for the right architecture. There are other AWS networking services. For example, the load balancer is there. They have the application load balancer, the network load balancer. They have a different endpoints, like S3 bucket is an endpoint that you can consume to connect to S3 buckets in a private fashion. They have private link, they have DNS service, they have a storage service, they have the global accelerator so that when your branches are connecting to AWS, they land onto the closest edge location, and then you ride on top of the AWS network to get to your destination. Okay. So next is Azure. Okay, so like AWS, Azure has their networking services. So what you will see in Azure is basically networking starts from the VNet. In AWS, that was VPC. Similarly, they have the VNet, which is the virtual network, which provides you the networking constructs, like exactly what you saw in AWS, but in a very different manner. They approach networking very differently there as compared to AWS. So within those VNets, you will create the subnets. So you can use those subnets to deploy your applications. And then you have the network interface card. They also have this concept, but in Azure, you will see it right out there. One limitation that you notice is that these NICs, when you deploy these NICs as part of the virtual machine, they all need to sit in the same VNet. And when I present GCP to you, you will see that this is totally upside down. So without, beside that, they have their DNS service. They have the public IP addresses that you can assign to the virtual machine. In this case, another difference between Azure and AWS is that when you assign a public IP address to your virtual machine will just start talking to the internet. In AWS, you have to do create the route associated and then create the default route. But in Azure, that's not the case, and you need to be really careful because you don't want your applications to just go out and talk to internet without any security in place. Okay, so when you look at Azure, they have a concept of region as well. You define your VNet, you create the subnets are there, the AZs are there to provide the availability at the data center level. Then within those AZs, you're gonna deploy your virtual machine, and SAP S/4HANA is gonna be one of them. Then you have other virtual machines. You can also create the network security groups or security groups to make sure these applications, virtual machines are not talking to each other, or if they're going to on-prem, you have some restriction in place or for the incoming traffic. So you can create those type of layer 4 firewall rules. When you need to connect to internet, you have a number of options. Either you specify the public IP, or if you're using the private IP, you have the NAT gateway option to connect to internet. So this is their icon for the Azure native NAT gateway. This is what you see here. You can also use, like I mentioned, third-party virtual machines, and they call them NVA, Network Virtual Appliances. So they can provide different functionalities. They can be a NAT gateway, they can become a load balancers or provide some other service. So if these virtual machines, they go down, you can actually use the load balancer, internal load balancer in Azure to load balance between those virtual machines. Obviously, you need to make sure there is no, traffic asymmetry and whatnot, but from a very high level point of view, yes, you can use these type of services. They have their native set of firewalls. Like I mentioned, you can specify the public IP. You have direct connectivity to internet. Yeah, that's for the internet egress. For the internet ingress, you can again use their Azure firewall. You can use the NVA, or you can use their VPN gateway to connect external devices from outside, from your SD-WAN or branches into your Azure network. So like AWS, they have their application gateway load balancer to load balance the applications that you would have deployed in virtual machines. So when you deploy these gateways, application gateways, you can enable some security features like the web application firewall. Obviously, you need to remember that every service you deploy, you need to pay for this. It's not coming free. Okay, so and then what you also need to remember that for some services you have to pay regardless if you use them or not. For example, AWS NAT gateway is an example where once you deploy it per hour, you're paying for it. And then they also charge you for the data that you're transferring. This is the same concept that you will see in each and every cloud. And they have done a really good job in terms of documenting it, but there are some areas where you really need to pay attention to exactly what they mean by 1 cents per GB. Is it between region? Is it within the same region? Is it when you're only connecting to on-prem? So you really need to double click on it. So it could become really, really confusing and a design exercise, in my opinion. It can take hours and hours just to decipher that. And then when you look at their bill also, their bill is not broken in a fashion that you can easily understand. So, but when you talk to them, they have good teams and experts just to discuss the pricing and then costs, and they're really good about it. Okay, so yeah, so for ingress traffic, you can use Azure front door, their CDN type service, and it comes with some security features as well. On-premise connectivity is, again, two options. One option is to use their native gateway, or the VPN gateway to connect to on-premise branches, connecting IPsec connectivity, or you can also use direct connect type service. They call it express route for their on-premise connectivity. That provides you the private connectivity to on-prem with the high throughput. When I say private connectivity, it means that there is some entity in the middle, for example, Equinix or Megaport or someone. Yep. So it's not 100% private. There's a party in the middle providing this circuit to you. Okay. So, and that's the reason that when you talk to enterprises, or when we talk to enterprises, they actually tell us that due to their compliance, their audit reasons, they cannot trust anybody. Okay. So they need to encrypt this link using IPsec, because IPsec provides you end-to-end encryption. The MACsec is there, but it's hop by hop layer 2. The IPsec is end-to-end layer 3, right? And once they do that, again, they run into the same problem where this express route becomes only 1.25 GB highway for the 10 gig circuit that they purchase and paying for. So they need a solution like Aviatrix to make sure that they're getting the line rate encrypted throughput for those circuits. So Azure has their own routing entity to connect different VNets together and then route the traffic between. And also you can attach the on-premise, but again, you need to quickly and carefully look into what they're providing. Is it meeting your requirement? Do you want any-to-any connectivity? Or do you want segmentation when you're connecting those devices? What about using a third-party firewall inside the vWAN? Does it support it or not? And if it supports, then what are the gotchas? What are the limitations in terms of that support? So you need to really go deeper into each and every cloud, or even a single cloud, and go really deep and understand all that. And that's the reason we are here to help you as a partner. As an Azure partner, we are here to help you. We'll sit with you, we'll discuss these requirements with you. If it makes sense to go with vWAN, we'll say, okay, go with vWAN. But if you're enterprise, if you're using SAP HANA business critical applications, then I can guarantee that these services are not gonna give you what you're looking for. So you need a platform like Aviatrix for that. A lot of design considerations when you're building this vWAN network. I will not double click on each one of them. You can actually go back to our Aviatrix Associate course, and you can replay the video where we have discussed this in more detail, but you need to know what those limitations are. That's the high level message I'm trying to provide here. So now we are moving into the GCP networking 101. Okay, so like in AWS and Azure, GCP also provides some services for their customers. And those services are in different areas. So there is again heavy emphasis on the compute in Kubernetes, in machine learning, the big data, BigQuery. This is where GCP, in my opinion, really excel. So they have a heavy focus on those areas, and they have created services around it. So they have the virtual machine concept. They have obviously IAM account concept. In case of AWS, when you log into the console, you have account. That's your like top level construct where you will see all the resources clubbed in. In Azure, it's a subscription. In GCP, they call it project. So everything is under a project. Your virtual machines, your storage, your interconnect, everything is under a project. And then you have the concept of DNS. They provide this DNS functionality. The load balancing is there, and then the storage options are available. So like I said, when you are deploying a resource in GCP, you have to start from the project. So first thing you do, you create a project. Okay? And this project contains your VPC. Okay. So, but the most important thing to remember here is that when you create a VPC in GCP, it can stretch across the globe. Okay, so this VPC can contain subnets that can sit in any region in the globe. And this could be something you need to watch out for, because when you're deploying your applications are region bound. Okay, and then when you create those VPCs, what I recommend my customers to do that, although GCP supports this notion of global VPC, it's not really a best practice. Even when you look at GCP documentation, you will notice that. In some cases, it could be that you use the global VPC, but in majority of the cases, especially when you're deploying the business critical applications, where security segmentation is important, we're making sure that these applications are not talking to each other in a global VPC format is important, then you need to divide your VPCs and make them region bound. So again, VPC, you create the VPC, you have regions, you have subnets, and then you start deploying your virtual machines, SAP HANA VMs in those subnets. In case of GCP, there is no top level seeder. So you actually work on at the subnet level. You can create the rules to allow the communication between those virtual machines or deny the communication, or if they're going towards the internet, or if the traffic is coming from the outside. You can do all sort of things. So when you log into GCP console, you create your project, you click on the VPC networking area, and this is where you can create the VPC. Now, this VPC can contain one or more subnets, and your subnets can be created in the auto mode or custom mode. So when you first create the GCP VPC, it will ask you that, do you want me to create the subnets in the auto mode? And you should say no. Why? Because if you select auto mode, it will create all the predefined subnets in all different regions in GCP. And that's not the best practice, because you want to make sure when you deploy application, you deploy them in a proper subnet. You have a proper planning done beforehand so that you're not overlapping any subnet. So make sure you choose a custom mode and define your own subnets in regions. Okay, so GCP has these regions and zones, as we talked about. Then you have the subnets. When you create the VPCs, you can use VPC peering to talk to each other, because in AWS and Azure, we had this service in AWS called TGW. In Azure, that's vWAN. There is no such service in GCP. So you are only dependent on VPC peering for these VPCs to talk to each other. Like other clouds, they have their own implicit routing running behind the scene, where when you create the subnets, they start talking to each other. For the on-premise connectivity, for connectivity to branches, they have their VPN gateway that you can use. And then, like I mentioned before, in AWS, the VPC has this regional boundary. In GCP, you can create a VPC globally, but your subnets are always going to be region, because obviously these subnets are sitting in some data center somewhere in the on-premise. Yeah, so you can use the VPN gateway if you are talking to the on-premise or if you're going towards the internet. What are the VPC design best practices? Because this becomes very critical in GCP. You have not seen me talking about the VPC design itself a lot in AWS and Azure, although it's important, but in GCP is extremely critical. Because like I said, you can create these VPCs across the globe, but the challenge is that you need to make sure that you are providing proper segmentation and encryption and service insertion. Because when you create these virtual machines in a single VPC, you cannot just insert a third-party firewall, next-generation firewall for a traffic that is happening inside the same VPC, because at that time, the implicit routing will take over and will just route the traffic between those virtual machines. So in those type of situations, it's very important that you create multiple VPCs. And this is exactly what GCP is also telling you about. So when you go to their best practice VPC design guide, you will notice that if a customer has this business critical application deployed, and if they need proper segmentation, service insertion, they should go and create multiple VPCs, the region-bound VPCs. The Cloud Interconnect is their service for the on-premise connectivity, the high speed, high throughput on-premise connectivity. And within the Cloud Interconnect, they have the dedicated interconnect, where you have only two options, 10 gig and 100 gig. And then they have the partner interconnect, where you basically have a service provider in the middle. And here you have different options in terms of throughput that you can purchase from them. But like AWS and Azure, they run into the same challenge. It's a limited encryption support. And when you encrypt at the IPsec level, it's only 1.25 GB. So that's the cloud limitation in general. Okay, so that's GCP 101. And the next section is the multi-cloud network architecture. Okay, so let's step back a little. We discussed the cloud networking. Let's go back to the on-premise networking and see how the networks are being built in the on-premise data center and how they actually evolve. So obviously, when Cisco started this momentum in early 90s, where they said, you know what, the IP-based networks are going to be the one providing the networking for the applications. It was obviously a paradigm shift, and it took industry a while to come to the point where they said, okay, we need a reference architecture if we are deploying all these networking resources in the data center, because you cannot just put them in flat order, right? So that's the reason they created this, the access aggregation and core architecture, where the access requirements are completely different than the core requirement, right? In the core, you need high speed backbone. You need specific services in core, where in access layer, where this is where your applications are, or servers are connected to, you need, a completely different type of networking. And the teams are also different when they're managing these networks. So there is a core team, there is an access team, and they have their specific tooling, and their expertise in terms of managing it properly. So then this evolve into the leaf and spine architecture, which is sort of similar because you have this spine layer and all your leaf switches are now connected to this spine layer, right? So this is what they created. And then when they created this architecture, there is a notion of pod as well. Okay? So you have a pod, and then you manage this pod, and then this pod has connectivity to internet. So there is a DMZ pod, DMZ zone, where you have the internet connected. It's a caged system, it's a lockdown system. So they created all these reference architectures to make sure that the applications are getting what they need in the fashion that is desired by the enterprises, because these applications are business critical applications like SAP HANA or the Epic Healthcare or other applications. But when they come to the cloud, when the cloud momentum started, nobody was thinking about a reference architecture. The momentum was started by the DevOps and the cloud engineers. So they started deploying these applications without having a proper reference architecture in mind. So when Aviatrix started working in this space, this is what we realized. And we said, you know what, we need to give this reference architecture to the industry so that these applications can be deployed in the enterprise manner. So that's the reason we created this MCNA architecture, which has a notion of access layer. It has the transit core or the backbone. Then you have the application layer. This is where your virtual machines, EC2 instances for SAP HANA are sitting. And then what you need a security which is consistent across these layers. And then the operation has to be consistent and seamless across these layers, right? And then you look at this architecture, there is no Aviatrix here. This is a reference architecture. And then this is how we educated the industry to deploy the applications in single cloud, in multiple regions, across multiple subscriptions, projects, accounts, across multiple clouds. How do you actually connect the on-premise using the access layer, using Direct Connect or the branches? And then we said, you know what, this is a repeatable architecture in the cloud, because now we're providing the centralized control plane, which is the Aviatrix controller. It is making sure that all the route programming, security, intent is being realized across the board. And then we also gave this notion of centralized the automation plane with Terraform or with the API access. So that's what the reference architecture looks like, and that's what it provides, which is basically the consistency and ease of use. So you don't have to worry about all these limitations I spoke about before, because we took them into account when we built this platform, the Aviatrix platform. So you don't have to do all this heavy lifting. And when customers are deploying this using the MCNA architecture, this is how it looks like. This is a blueprint of an enterprise that is present in 3 clouds, and which is very common, by the way. And they're using our platform to make sure the SAP HANA and other applications are designed and architected properly. So you have the backbone here in the middle, the Aviatrix backbone, which is connecting to these applications, VPCs and VNets. This backbone is also responsible for providing decentralized firewalling, because cost optimization is important. You don't want to put your next generation firewall each and everywhere. And then it has also the connectivity back to the data center with the high throughput encryption and supporting overlapping IP and other use cases that you commonly see when you are integrating with a partner service or if you have mergers and acquisition situations. And now you can put things in perspective, because now you know in the cloud security, that's what you need to provide. In the operation space, you need to make sure you have the packet capture, health analysis, anomaly detection, total visibility and control. The backbone has its own feature and own requirement that you can now capture when you are building it. And then on the on-premise side, obviously you have different connectivity options like SD-WAN, your user VPN, users are also coming in, and that's also being covered as part of this architecture and this design. A lot of information is available on YouTube with these links, and then I'm going to provide this in these PDF presentations if you send me an email. and you will get all these references as well.